Hello everyone. I welcome you all to this course first of all. So this course is all about the Python basics for mathematics and data science. Okay. So first of all, what do you mean by data science? Data science is nothing but analyzing a particular data and producing some inferences based on the data. That's what we mean by data science. Okay. Studying the data. So why data is so powerful? Say for an example, you have say for an example you want to predict the prices of house, right? Prices of random houses. Okay, so the price of house depends upon certain factors. It means the number of rooms in that house, the square feet of that house, the location of the house, that is where it is located, either in a remote area or a rural area. I think both the same. I'm sorry, remote area or urban area. So it all depends, right? So you have to the machine learning model is basically interconnected to machine learning. So machine learning actually the model has to study all the futures. That means all the sold prices, the past sold prices. Like this house has this much number of rooms and it has been sold for this price. It has to study the relationship between all these, and it has to predict the same for the future future houses also. If I give a new house that has not been sold based on the previous data, it has to say whether it is sold or not. For that we need data science, right? Because the machine has to analyze the data and produce some inferences from it. That's the main aim I will be telling you. Analyzing the data and producing some inference from this. Okay, analyzing I hope I'm not wrong. Analyzing the data and producing some inferences. Producing the inferences or in something inferring. Okay, like the machine has to understand. Only if you analyze the data you will be understanding that this has a trend. Okay, this has a linear this particular column has a linear trend with this. Say for an example, will we we are currently now in COVID-19, right? COVID-19 pandemic. You take an example, the number of test cases in every country. Okay, so the number of tests that they are taking in every country and the number of positive cases reported, they are almost directly proportional, right? Almost. Of course it depends upon certain other factors also, but almost these two factors are directly proportional, which means the more number of COVID-19 tests you take for people, the more number of positive cases will be reported, as of now, right? So these are almost linear, so you have to analyze the data and produce this inference. This is actually an inference, right? So I'll study these two you know columns, right? So the more number of test cases, I'm talking about COVID-19 now. So in COVID-19, so in every country, in almost countries, so many countries, so the more number of tests that you are taking, the more will be the positive cases reported. Okay, it almost it follows in almost all the countries. So that's it. I'm not going to I'm not going to debating topic. Okay, so this may depend upon certain other factors also. In many countries it has been suppressed. Now I'm happy for that. Okay, but still it's there in some countries. Okay, so COVID-19. So yeah, that's it. You have to analyze that two features and you have to produce one inference. I already told you the inference, that is the more number of test cases you take, the more will be the positive cases will be reported, right? So this is the inference. Like this, the machine has to analyze the data and produce some inferences, not in the text form but in some other form. I'll tell you data. Fine. So that is actually all about data science. Okay, data analysis. Okay, so and it has some sub branches like data engineering, and or in other words I can say future extraction or future engineering. That and all it's beyond the scope of this course. Okay, fine. And we are going to mainly focus on the Python basics. That means to start learning data science, or to start learning you know to start learning machine learning. Okay, it's something cool, right? To start learning machine learning, so you have to get into the field of AI. You have to know this one library. Okay, not this one. You have to be thorough in a lot of libraries, but I'm gonna tell you one in this course. Okay, that's the basic library that we will use mostly in data science. Okay, so that's Numpy. And also we will be focusing on math. Okay, so I'll be telling you how to calculate mathematical expression. This course is actually mainly focused on math, and it will be a balance between math and data science, to be honest. Okay, so So we'll be seeing two main libraries, everything about these two libraries. You have a lot of functions there. I'll be explaining everything. Okay, so Numpy and Sympy. Fine. So sounds rhyming, right? So that's it. Numpy and Sympy, and we'll be having an overview on some other libraries also, like pandas, etc. Fine. So the mathematics content that we are going to see in this course are all about the matrix algebra. So you have to know I assume that you know the basics of matrix. Okay, the matrix algebra, like you what is the, when I say matrix, what is the what do you mean by the order of matrix, and how to multiply two matrix, how to add two matrix. I hope that you know that. Fine. And if you don't know that, I'll tell you I'll give a brief about it. At the time when we are talking about numpy, when I'm actually coding it, I'll give a brief about it, but it's highly appreciated that you have to know the matrix algebra. Fine. And basic calculus, of course, how to integrate and differentiate using Python. Is it possible, right? And we'll do that now. Okay, we'll do integration, differentiation, limits taking, like we do basic calculus using on interesting library called as Sympy. Okay, and that will definitely work. We'll do that, and I'll tell you how to do that, so that in I'll be doing one more course on this, and on GUI projects we'll develop a project on we'll develop software based on that. Okay, in the next course. Fine. And quadratic equations, yeah, I'll be telling you how to solve quadratic equations using Python libraries. Fine. This is all very cool stuffs. Okay, and you have permutation and combination. I'll tell you what is permutation and combination, how to calculate the same in Python using these libraries. Fine. So that's it. That's all the content you have in this course, and this will be very, very interesting. Trust me. Fine. So, and of course you have some prerequisites. This course assumes that you have a basic knowledge in Python again. So the prerequisite must be you have to know about list and dictionary, because when you are talking about numpy, we have a data type, they are called as numpy arrays, and that is actually what I can say, a superset of list. Okay, so this is actually based on list. Okay, so you have to know list and dictionary. Fine. Yeah, that's it. That's all about the content, and see you there in the next video. Hello guys, welcome back. In this video, let me tell you how to install NumPy library and SymPy library in your computer. You have to install that, okay? But if you are using Anaconda prompt, if you are using Anaconda gateway, that's a package, it will be defaultly installed, no worries. But if you are using pip, you may be using pip or Anaconda, right? I assume that you know what is pip and Anaconda terminal. So if you don't know, it's not, it's just a gateway. Anaconda is nothing but a gateway to install all the libraries. And for the beginners, I'll say go to your browser and search Anaconda prompt. Anaconda it's actually a distribution that you that will come with some like packages in Python. Okay, some standard packages like NumPy, pandas, and we'll see what is pandas later. The basic overview that will do. And scikit-learn, for like scikit-learn is a very good library for machine learning stuff. So these libraries will be accompanied with the Anaconda distribution. So you can actually install that. It's actually very simple to install, to be honest. Okay, go to Anaconda distribution. Just search Anaconda distribution in Google or Bing, and in the first link itself, that's open source, to be honest. So you have the it's open source ecosystem. You can see that, and yeah, individual edition is there. You can click that and you can download that. Once you have downloaded, you'll get all the libraries. Yeah, it says data science toolkit. You'll get all the libraries in this. Click download or go back. Go below, go to your, there will be something. Yeah, you have Windows, Mac OS, and Linux. Okay, for all the OS they have uh, uh, Anaconda, it seems like, and they are most used to OS operating systems like Windows, Mac OS, and Linux. Okay, you can actually install this and run in your computer. I would highly suggest you to install this. Fine. So again, it will take time for you to for it to install in your computer. That's fine. So we have opened the Anaconda prompt. Okay, after installing the Anaconda, you go to search and research Anaconda, right, in your search command, and it will open Anaconda prompt. So you have to open that. I have opened that for you already. So in Anaconda, let's install pandas. Either you can use conda install, let's install numpy first. So either you can use conda install numpy or pip install numpy. I'll use pip here. So pip install numpy. If you don't know what is pip, it's again a gateway to install the packages. And I told you that it will be automatically installed whenever you are downloading and installing Anaconda prompt, because Anaconda comes with some certain packages. I told you that it's a data sync toolkit, and it comes with some standard packages. Okay, that's why you have a lot you have a lot size there. You can see it's a pretty good package, right? You have a 400 MB, sorry, Python 3.7, yeah, 470 MB, so it's a pretty good package. It comes with a lot of libraries, fine. So it will be automatically installed, but let me check whether it is present or not. Pip install numpy, it should show me requirement already satisfied, fine. So if it doesn't show me required already satisfied, it will be collecting data and it will be installing for you, and it will be taking time. And you can see we got the output requirement already set, which means that I have already installed numpy in my computer. I didn't install, I just installed anaconda prompt, and it came with anaconda prompt, it seems. That's why it says requirement already satisfied. And I'll check how to check what are the libraries present in this anaconda prompt. I'll say pip plus enter. I think it will give the list of libraries which is present in my prompt. Hey, wait a minute. I think it's list. Okay, so pip uh, pip list. Yeah, pip list. Let's wait for a while. Yeah, you can see we have a lot of libraries here. So I hope we have, yeah, we have numpy also. So you have a lot of libraries here. These are all libraries which are available in my computer in Anaconda. And again, I've installed a lot based on my needs. You can also do that. Let's just if you want to install library, plus pip install and the library name, that will install it for you, right? So that's it. That's all about installing numpy, I hope. And you have to install one more library also, and that will not come with anaconda. I hope, I think it will not come with anaconda. That's sympy, right? So pip install sympy. Let's wait for a while and check what happens. This is also already installed because I've already installed it in my computer. I'll leave that. Okay, so yeah, I'll close this. I don't know this, I don't need this now. So let me go to my notebook, my IPython notebook, fine. And again, this is an interactive environment to write your Python code. That's it. Okay, just think of Visual Studio Code, and yeah, you can write your Python code here, and you have something called as cells, so that your code will be split. Okay, so you can have plus plus plus, and you can your 50 line code can be split in these cells. That can be done. Okay, that can be easily done. Okay, so you can also insert cells, and you can insert something, let's say print hello world. Okay, you have to, if you put enter, it will go to the next line, so you have to press shift and enter to execute that particular line. Please remember this. If you press enter, it will navigate you to the next line. You have to write your code. If you have only one line code, in other words, if your code ends in that particular line, you have to put shift and enter to execute that particular line. And if you have executed, it will give you a number on how many the number tell you which statement is actually executed. It's the first statement actually, so the number tell you, right? So if you are executing, it will give you an asterisk sign that we will be you will be familiar with it when we are start actually working with it. Okay, and if you, no problem, if you don't like this, no problem, just go and work with Python ideally, or something called as Visual Studio Code. Okay, that will also do. PyCharm is also a very good ideal. You can also use that. Okay, you have a lot of ideals available, so you can use anything. That doesn't matter. Thank you. We'll see you there in next course. Hey guys, welcome back. So yeah, we are going to actually start using the NumPy library in this video. So for before that, let me tell you how a matrix will look like. You may be knowing it, almost everyone might be knowing it, but for this discussion I think it's necessary to explain with this also, right? Fine. So let me consider a matrix. Say I have a 3 by 3 matrix. That's how you pronounce that, right? 3 by 3 matrix. When I say 3 by 3 matrix, you have 3 rows and 3 columns, right? And this is a, I think this is called as square matrix. It's 3 rows and 3 rows and 3 columns. Yeah, So when I say 2 by 3 matrix, assume that it is 2 rows and 3 columns. You know what are rows and columns, right? Rows are nothing but horizontal rows and columns are vertical columns which are available there. And I'll tell you about it. Okay. So let me create a 3 by 3 matrix of some random elements. Fine. So 10 space 20 space 30, go to the next line, 40, 50, 60, go to the next line. I think a line is extra creative here. We don't want that line, right? So 70, 80, 90, and that's how a 3 by 3 matrix looks like, right? Fine. You have 3 rows and you have 3 columns, right? So I couldn't point out that you have 10, 40 and 70 is one column, 20, 50, 80 is another, and 3, 30, 60, 90 is another column. At least you have 3 rows and 3 columns, and this will be a great stuff for a beginner, right? So row 0, that's actually called as row 0 in Python. Please remember this, okay? So because Python, mostly programming languages have 0 based index, so that starts from 0. It's row 0, row 1, and row 2, but you have 3 rows there, okay? So when I say 3 rows, it actually goes up to, it starts from 0, goes up to 2, which means when I say n rows, it starts from 0, goes up to n minus 1. Fine. So you have 3 rows and 3 columns, and 10, 40, 70 is column 0, 240, 250, 80 is column 2, column 1, and 360, 90 is column 2. Fine. So that we have 3 columns and 3 rows. That's how a matrix looks like. Let us create this in Numpy arrays. Okay. So the idea is creating, how to create a matrix in Python. To be honest, if you are from C or C++, you can use a multi-dimensional array, right? You can use 2-dimensional array to create a two-dimensional matrix, right? So here in Python, so there it is 2-dimensional array, but here in Python, we the first idea will be using nested lists. Fine. So you know what is the list, right? So I'll be going to my IDLE now. So this is my interactive environment, Jupyter environment. I told about this in the previous video itself. So no worries. Let me create a list for you. Let me say a 1 2 3 2 3 4, right? So this is a list, okay, and that's how you can create a list. So let me print the list and show it for you later. It will definitely show me 1 2 3 4, and this course assumes that you have a basic knowledge in this, fine, in list operations. And how to create a two-dimensional list, that means a matrix, okay. That's pretty simple, right? Let me say I want to put 1 and 2 in first column and 3 and 4 in second column. Fine. So that will be easy, that can be easily done. You have to open the outer list first. Think of the matrix outer line, okay, outer list, and inside this you can have one more list, say 1 comma 2, and you put comma, you can have one more list, say 3 comma 4. That's how you can create a nested list. So this means that 1 comma 2 will be occupied in first row, and that means 0th row here to be more precise, and 3 comma 4 will be occupied in the next row after 0, which is first row. Fine. It's row 0, row 1. Now you have 2 rows, 1 column. Now 2 rows, 2 columns actually. 1, 2, and 3, 4. Actually, we have 2 elements, so it will be occupying 2 columns. To be honest, let us print this and check. So this is a 2 by 2 matrix, and this will look like this only, because for computer it's actually a nested list, but in our point of view it will be looking like this, right? So 1 2 3, yeah, it's a 2 by 2 matrix, right? So that's so first 1 2 should occupy the first row, and 3, that means 0th row, and 3 comma 4 occupy the second row. That's how we have written the code here. You can see that's how we have split, in the outer list we have split the inner elements into 2 lists. That's how each list is a row, right? So this list is a row and this list is the another row, right? So that's how it works, nested list works, but it will not be suitable to compute a lot of mathematical operations with this, because everything, not everything, I'm sorry, it's not everything. Again, some of the things in data science will be, depending upon matrix algebra. Fine, like for example, in machine learning also, if you want to, recognize an image, how do you store image in this Python program? Okay, you have to, the image should be in text form, right? Not be text means include numbers also. When I say text, include numbers also. The image should be in numerical form, right? Then how do you write your code with image? Okay, if you are recognizing an image, an image will be converted into a lot of pixels. Again, the pixels will be analyzed, and each pixel will be an RGB value, and that will be stored in a two-dimensional matrix. Again, for you to analyze that matrix, you have to know the basics of NumPy again. So you have to depend upon NumPy to actually analyze that two-dimensional matrix, which is actually your image. Your image can be represented as a two-dimensional array of pixels, right? RGB values. Fine. Again, if you don't understand this, no worries, and that will be you'll be seeing in future. Okay, fine. So we'll be talking about basics here. No problem. So you understand that you have the use of this library in a lot of machine learning and data science applications. Fine. So let me delete all the nested list. Actually, we don't need this. Okay, and it will not be helpful for us. Okay, fine. And yeah, let me import numpy library now. So import numpy. Fine. So if you want to import numpy, you can import like this, but it's highly recommended to import it as np. Fine. So what is as command? I assume that you know what is as command. I think it's nothing but if I import numpy in every line I am writing, I have to put numpy dot, and I have to sorry, I have to put numpy dot, and I have to use numpy dot, and I have to use a function like that. Okay, function which is present in numpy. Again, that's in every code. If I type numpy, that's actually it takes more time, right? That's why I'm importing it as np. So throughout my code now I take it as np. Okay, that's giving a different name for an existing module. That's very simple stuff in Python. Okay, as command will give you a different name. Okay, throughout this, if I execute this line, you can see we got an asterisk line which says that it is executing, please wait. Okay, we got a number there, so it is actually executed now. You have actually imported the numpy library successfully, so no doubts. And you can use your np to represent numpy. So think of that you have a pet name. Okay, that's it. Okay, fine. So numpy has a pet name now, np, and you can actually use numpy using the pet name np. Fine. So np, I'll type. Yeah, it will show you. If I type np, it will show you it is the module numpy. Fine. And it is present in the anaconda library or anaconda distribution, to be honest. Fine. Okay, fine. Let me create a two-dimensional matrix for you. For that, I'll just go to markdown here, creating a two-dimensional, or creating a matrix. Okay, fine. Yeah, that's a topic. That's a topic I want to just so that you can use this actually. So creating a matrix. Let me go to my code. Yeah, it's actually in code mode. Not worry. So you can create topics and subtopics. If you don't know, you can create topics and subtopics here in this notebook, so that will be easy to read the code. Okay, that's why I'm using this. Creating a matrix. So how to create a matrix using numpy library? That's pretty simple. Okay, so let me declare a variable or object. In Python it is called as object to store my matrix. Let's say x. So x will have the matrix now. So x numpy dot array. So you have to use the array method to create a matrix in numpy. Fine. So you have to use the array method. So we have a method called as array, and you have to use that to create a two-dimensional array. In this case, it's called a matrix. Okay. So two-dimensional array is nothing but called a matrix, right? So you have rows and columns. That's actually a two-dimensional array. That's it. Fine. That's why it is called as two-dimensional row and column. Fine. So the idea is same. To be very honest, the idea is actually same. You have to create a nested list here itself. Okay, you have to create a nested list. So you open the inside the braces. That means this denotes again, I'm repeating this, parenthesis denote that array is a method or a function. Okay, again it's a method only. So array is a method or a function which is present inside the np library, and np library is nothing but the numpy library. Fine. So numpy library, we have a method called as array, and I am using that inbuilt method. Okay, fine. And inside this you have to provide your matrix in the form of nested list. Okay, so please understand that. So for nested list, I have to create an when I say nested list, is list inside a list. We have seen that a while before. So I have to create an outer list now. So inside the outer list I have to create my rows. Okay, so let me say first row will contain 1 2 3. You put a comma, you open one more list, put 4 5 6 will be occupying the first row, which means the second row, I mean this will occupy the 0th row, and this will occupy the first row. Okay, so let me create a 3 by 3 matrix. Fine. So let me say 7 8 9 Fine. So that's how you can create an outer this, look at this square brackets. This actually represents the outer matrix. Okay, that's an outer list. Okay, it's a nested list. Okay, that's it. And inside this you can, this actually represents the matrix outer square brackets that we will be usually have in mathematics, right? The matrix matrix array structure. Okay, the outer structure or square parenthesis that will be usually having in mathematics when you talk about matrices. Then that's exactly this. And this square brackets individually represent a row. Please understand this. Okay, so 1 comma 2 comma 3 will be occupied in one row, and 4 comma 5 comma 6 will be occupied in another row. It's like that. This goes on. Fine. Okay, let me execute this. I plus shift enter, feel free to do that, and I'll be creating a matrix. Let's say x. Okay, or in the, to be more precise, let me print x. Okay, yeah, you can see we have created a matrix in Numpy. Fine, super that. Okay, so you have the first row, which is 1 comma 2 comma 3 4 comma 5 comma 6 7 comma 8 comma 6. You can see the commas are all demolished here, right? So that's how a matrix looks like, right? So when I create a nested list, it will be having the commas also with me, right? I don't need that in matrix. We don't have that, right? Every element should be unique and considered as unique. That's why we have a matrix kind of structure right here. So that's it. First row, second row, third row. I hope you understood how to create a matrix in Numpy. In our next video, let me tell you how to access elements from the same matrix. Thank you. Hey guys, quickly moving on, let me tell you how to access elements from the matrix. It's actually pretty simple. Okay, it's almost similar to list indexing if you are very thorough with list indexing, but there will be some confusions here. I'll tell you what. Okay, so here assume that you have two two dimensions. Okay, row and column. Fine, so you have to do indexing for both the dimensions, then only you will be getting the output. For example, I'll say x of 0 comma 1. Let's check what it gives. Yeah, it gives 2, which means when I say 0 comma 1, it goes to 0th row, which is first parameter actually represents the row. It goes to 0th row, so that's the 0th row here. And first element is 2, right? Don't think 1 is 0th element. Okay, it starts from 0, so first element is true. That's how it prints 2. Okay, that's why it prints 2. Sounds good. Fine, so let me show you the another kind of indexing. Say 1 comma 2, and that will go to the first row, that is 0th row, and first row here, the first row there, and second element, which is actually 6, because 0 1 2, second element is 6, so 1 comma 2 will be 6. That's how we can access some elements. Okay, let me consider if you want to access the whole row. Fine, if you want to access this row again, this row alone, that's pretty simple. Put x of 0, and that will give you the whole row. Fine, and you can see we got something called as array. It represents the data type. That's it. If you want to neglect that, it's pretty simple. You just print this. Okay, that's it. Okay, so yeah, x of 0 will give you 1 comma 2 comma 3. Fine, so again, naturally a question arises. You can access rows, a single row. Whether you will you be able to access a single column, right? 1 comma 4 comma 7 2 comma. Is this possible? Of course, is this possible? I'll tell you why. But that's a different stuff. I'll be telling you now. So that's how you can access a row. I think I should write a command here. Access a row, an entire row. Okay, access an entire row. Please remember this. And you have the difference is you have two indices here. That's an element. Okay, accessing an element. Fine, a single element, you can do that. You can actually use this also. There is one more method. If you say, for example, if you want to access the same two element, you can use this kind of approach also. 0th row, and you can also put one more braces to go to 1. Okay, that will also give you 2, no doubts. Okay, that's also possible, but that's what we usually do in other programming languages when you talk about two-dimensional arrays. Okay, in other programming languages we'll do that, we have to put two square brackets and indicate the first one is row index, and the second one is actually column index, that's C1. In this case, I'll be highly recommending you to go with this, okay, because that will be helping you to understand a lot in this accessing and indexing. I'll tell you what, okay, I'll tell you. So go with this, okay, go with this idea. So if you put comma, that means actually separating row and column. So first is actually representing row and second is actually representing comma. Fine. Okay, let me go move on, and I'll tell you how to access row. Before that, this is called as indexing, right? These approaches are called as indexing, that is accessing a particular element. Fine. Let me do slicing. Okay, is it possible here? Of course this is possible. Let me do slicing, and I assume that you know what is slicing. Okay, if you don't know, don't worry, I'll be no worries, I'll be telling you that. And if you don't know, I'll be highly suggesting you to go with list first and then come back here study about NumPy, because list is actually pretty important. Fine. So when you understand list, here you can understand NumPy. That's the case. Okay, slicing. But anyways, I'm explaining from the basics. I hope, right? I hope I'm not doing my job wrong. Okay, fine. Slicing. Okay, slicing means indexing. These steps are called as indexing, like x of 0 comma 1 1 comma 2. These steps are called as indexing. But when I say slicing, it will slice the matrix for me. For example, it will take a particular it will start from an element and it will go to the go up to the particular element and will slice the matrix and will give it for me. Like, think of like an apple. You have to slice the apple into 4 pieces, right? We have to cut the apple into 4 pieces, so like that. Okay, so we have a two-dimensional matrix here and I have to cut a piece in that. Okay, for example, I have elements from 1 to 9, right? So I just have to start from 1 and I'll be going up to 5. Say for an example, is this possible? This is called as slicing, and you'll be getting 1 2 3 4 5, right? That's how we can slice the matrix, and I'll tell you how to slice, and this will be pretty confusing. Then please try to follow. So for slicing, you can actually let me say comment. So for indexing, you can give two numbers here, right? So a comma b. Okay, so that's how we can give a represents the number the row, and bth column. I'll say inj instead of a and b. That's something weird, so I'll say inj. Fine. So I represents ith column, sorry, ith row, and j represents jth column. You know that. Fine. So if I say I equals to 0, that's 0th row. It's the first row here. Okay, so if I say j equals to 0, that's actually the first column. That's the 0th column. Okay, fine. First column means in context with mathematics, it is the first column. Here in Python or almost in any programming language, it is 0th column, right? You'll be knowing that. Fine. So that's how you can slice. Fine. That's how you can index, right? So slicing is actually pretty simple. Let me say you have to slice a row, and this will be fetching you only one value, but I have to slice, I mean I have to take a piece from the matrix. Okay, so that for that I'll be starting from I goes up to j. I'll be starting from, let me say I1. I'll be going up to I2. That will be done in my row. Okay, that will be done in my row, and I'll say j1, and I'll going up to j2. That will be done in my column. That's how you have to do slicing for both the rows and columns. Super bright. So you have to do slicing for both the rows and columns, and trust me, this will definitely work. I'll tell you how. Okay, that's common, no problem. So yeah, that's the point I want to insist. You have to do slicing for both rows and columns. Fine. Let me give you some examples. Let me execute this. So x of let me slice from 0 and 2. Okay, let me slice from 0 and 2 comma, I'll slice the column. I need 0 and 2. Fine. Check what happens, and this gives like this. Okay, okay, why it prints like this? Let me, before that, let me print the original matrix and analyze. Okay, I think it's plus printing original matrix like x. Yeah, it printed the original matrix, so that I can differentiate and show you. And I have sliced this, which means my row should start from 0 and it should go from, I should start from 0 and it should go up to 2 minus 1. Okay, understand that. I assume you know that if you put 2, it will not go up to 2, right? It will be going up to 2 minus 1, which is actually 1. Okay, so it will be going, if you put 3 there, it will be going up to 2. If you put 10 there, it will be going up to 9, right? So it will not be going up to the last, okay, so it will be going up to the last value minus 1, which you say, which is, in say for an example, you have I2 here, okay, it will be going up to I2 minus 1, that's why, right? So it starts from 0, that's no doubts, and it will be going up to 2 minus 1, which is 1, so it will be taking 0, start from 0 and going up to 1, right? I hope you understood, right? So it will not be going up to 2, it will be 2 minus 1, that's 1. So it will be starting from 0 and going up to 1, okay, so row starts from 0 going up to 1, so you have two rows there, okay, 0th row and first row, and that two rows getting printed. Fine. And column is the same approach, okay. When I say column, it starts from 0 again, it starts from 0 and it is going up to 1, right? Because here it is, when I put 2, that is 2 minus 1, last element will not be included, so okay, 2 minus 1, so that's 1, so it starts from 0 and going up to 1, so you can see we got 0th column and first column. 0th column is 1 comma 4 and first column is 2 comma 5. That's how we can slice the matrix. Now this is a two-dimensional matrix, okay. How to find that? If you don't know, let me store this in some other matrix, say y. Fine. Let me print y here, and that prints the same matrix, no worry. And if I say y dot, wait, that's it. So let me print the shape, y dot shape. I think it's an attribute, not a method, so y dot shape, and you can see we got the output, that is 2 comma 2, that is a 2 comma 2 dimensional matrix. That's it. Because shape of, you see the shape of y, it has 2 rows and 2 columns, so shape attribute will actually give you the number of rows and number of columns. Say friend, this will be very useful if you have a large kind of matrix. Think of a matrix which is 1000 rows and 1000 columns. You it's a possibility that you might have a matrix of even higher dimension, we have even higher numbers than that, okay. So y dot, let me say x dot shape, let me check that also, and that should print 3 comma 3. I just don't want this x, I should print 3 comma 3, that works. Actually a question arises, can I create only square matrices here? That's the same number of rows and column. It's not an issue, you can create any type of matrix. Like I'll say z, I'll say numpy dot array, I'll be saying that 1 comma 2 comma 3, and I'll be saying the next row will be having 1 comma 5 comma 6. Now data type not understood, I have to put that in next nested list, right? So we have to create the outer list also, and only it will be accepting. uh, I think I got two braces here, sorry for that actually. Fine, so let me print z. So z prints, yeah, 1 comma 2 comma, you have 2 rows and 3 columns. Okay, let me check the shape, and you can see we got output 2 rows and 3 columns. That's how we can slice the elements. And the important thing is I have to tell you how to access columns, right? So let me have some fun, okay. Let me stick with the x itself. So let me print x here, let me stick with x. So that's how we can x. So now we can slice the column. Let me say I want to slice the first column, okay. First column is 1 comma 4 comma 7, right? I want to slice that, let me assume that, okay. For that, my row should be, I have to get 1 comma 4 comma 7, but the point is I want to get the column elements for all the rows, right? So my idea is I have to get the first column, I don't care about the rows. Fine, I have to get the first column, that's my idea. 1 comma 4 comma 7, for all the columns I have to get the first element, first column. For that, hey guys, welcome back. I think in this video I'm going to tell you how to access the a particular column. We have seen how to access a particular row. That's pretty simple. You just mention the row index, do nothing for columns, and it will print the rows for you, entire row. Find that, and just I have printed x for our understanding here. I just printed x again. That doesn't matter, right? So let me try to access the columns. Let me say I want to access 1 comma 4 comma 7. Again, this is not possible this will be giving a tough for you in next nested list, but here it is very easy, right? 1 comma 4 comma 7, I want to access that. Fine. So how do I do that? That's pretty simple, guys. Actually, for that you have to put colon comma, say I'll give you an understanding. The first the parameter would be accessing the rows, second would be columns, right? That's how you can have, right? So recall, okay, we have seen that. Fine, you watched it, okay. You have seen that here, right? So first will be column. I told you go with this. So first will be row and second will be column, right? 0 is row and first is column, and it will give you an element. That's it, because you are not actually slicing, you are just indexing here. And we have seen about slicing, okay. It will give you a collection of elements from 0 to first column, sorry, first row. like that it goes here. That's why, that's what I'm trying to in this thing. First is row and second one is actually column. Fine. So for row parameter, I'll just put a colon. Okay, because I am trying to access columns here. Okay, let me put a comment. I'm trying to access columns. Accessing columns. Fine. So I don't care about rows. Okay, so I have to, when I say I want to access one column, and it should print that column for all the rows. For an example, 1 comma, I want to access 147, right? So that's a column. I don't care about rows, so I put colon, and that will give you that will start from the the least value you have, and it will be ending with the maximum value of rows you have. That, in other words, it will include all the rows. Okay, that's it, right? You don't want to slice the rows, you have to include all the rows. That's it. So that's why you have to put colon there, which means that you don't care about rows, you have to include all the rows. Fine. That's comma, that's colon, put a comma. If I say colon empty empty, that's it. Okay, starts from least value and goes up to the maximum value you have. Okay, you don't need to mention the value. So colon, comma, and after that you slice the columns. This is very easy. You put 0, that's it. 0 will be the first column. Okay, because when I say 0, it's the first column, right? So that will give you the first column. Yeah, you can see we got the output as first column. That's a vector. Okay, understand that a single row or a single column is called a vector in data science. I hope you know that. Fine. So 0, you got 1 comma 4 comma 7. Let me play with this. Say 1, you will be getting the first column. Fine. So first column is 258. You see that. Okay, 258 is the first column. That's the second column. In mathematics, here is the first column. Second column, that's the last column, right? So 369. So you got that. So you have to put colon, comma, the column number. Fine. So that's how it works. Fine. Superb, right? So in the next video, let me play with this more. Fine. Ta-da, guys. Hey guys, welcome you all. So in this video, let's talk about some functions in which are available in Numpy. Some interesting stuffs, to be honest. Okay, for that, let me open a new notebook. I hope because this notebook has gone up to 57, line number 57. That will confuse me. Let me open a new notebook. I'll close Anaconda individual. It's okay, fine. I don't need that. Fine. So now I'll just rename this notebook so that it will not be confusing you. So I'll say what's the name I could give, Numpy 1. Fine. So that's so this is Numpy 2, the second code we have. Fine. Numpy, so that I'll upload my notebooks in the last section, so that you can refer this for further understanding. Fine. So here so let's create a Numpy again. Now for that, let me copy the code, no doubts, right? So let me go to and let me import Numpy as np. Let me copy this. You have to import, whenever you use Numpy, you have to import that as np. That's np is community accepted. We have a community for Numpy, and it's most of the time everyone is using np. So I'll be suggesting you to stick with np, and you can use any name. If I say import np as mask, throughout my program now Numpy will be called as mask. But np is some standard kind of stuff. You have to you can use that. Fine. And that is accepted by the community. Okay, that's why I'm saying. I think you may be knowing the importance of community. If you have any doubts, you can go there, and if you want any output, you can go there and ask them, right? So you have a large community for Python libraries, to be honest, right? GitHub IO. So x equals to yeah, that's how you can create an Numpy array. Execute this. I've executed that, and let's print and see how it looks like. And that's how it looks like, right? So we have created a Numpy array. Wait a minute. You can understand the difference here. You got to gammas there. I think you have to print print x. Yeah, that's how your exact matrix will look like. Fine. So that's how we can. I'm gonna use some interesting function. Let me say I want to add all the elements. I want to find the sum of all the elements. How do I do that? That's very simple. I'll say sum of x. That's a function, not a method. So you have to include the function name. Put pass x there. Okay. That is printing x. Well, yeah, wait, that prints for separate elements. I hope so. Let me print np dot x. Yeah, that works. Okay, so the point here is, when I say sum of x, I have a default sum function in my Python itself. I know leave about numpy. Okay, let's keep numpy aside. I have some in my default Python library, right? That will be adding all the to be honest, that will be adding all the collection of values, iterable values. Let me create a tuple for you. Okay, let me create tuple 1 comma 2 comma 3 comma 4. If I say sum of y, that will print the sum of all the elements of the tuple. Fine. So sum is actually a basic function which is available in Python. Fine. So yeah, that will be printing the values. But here in numpy array, we have to use a sum function which is actually present in numpy. Okay, so that's why I'm printing numpy.sum. Okay, this sum function is different from this. Okay, this is some method which is actually present in numpy library. Fine, that's why I'm printing it as numpy. So you can see we got output 45. So stick with this numpy.sum. Okay, so you have to use the sum method which is available in numpy library. You have to use and pass your numpy object there. So that will be getting you the total number of the total sum of all the elements. I think 45, right? So yeah, you have to add all the elements and you see you will get 45. Fine. And you have some interesting function like minimum of x. Okay, 1. Again, it is very tough to deal the two-dimensional arrays without numpy. You can see when I use the the normal sum function in my Python, you can see we got some strange output, right? So you have to understand this output. Again, it's a list of elements, right? Because we don't want that actually. We have to want the sum of all the elements, and that is possible only with you have numpy libraries methods. Okay, so you have something called as minimum that will print 1, and you have maximum that will print the maximum element. I hope you know that. So maximum element is the highest element, that is 9. Minimum value is 1. That's how we print. And you can have one more lot of methods there. If you want to see that, put tab in notebook, press tab. You'll be getting a lot of methods. You have to wait that for a few minutes, and you'll be showing a lot of methods. I hope. I'll press tab again. It's not working. I hope. No problem. Fine. So that's how we can access some mathematical functions which are available in NumPy. But you have some interesting functions also. Let me talk about that now. Fine. So you have an interesting function called as mean that will calculate the average for you. You can see if you want to calculate the mean for a particular list, you have to find the sum of a list using a for loop. You have to use a for loop or while loop. For loop is most preferred. You have to add all the elements or use some function to add all the elements, and to by print average you have to find the number of elements. You have to divide by that print average, right? Here you don't need that. That's the beauty of NumPy. It's a scientific computing library. You just use the mean to give the mean. That's actually a float value that will return in float value, because average can be mostly in float, right? So that will be returning in the 5 is the mean of this 5 is the mean of this NumPy array. Okay, fine. Say for an example, the application of this would be, I'll say application of this mean function. Say for an example, I have a list, say a equals to, say squares equals to, I have a list. Okay, I have a list there. Okay, so not NumPy, I'm not talking about NumPy here, I'm just having a list, that's it. Fine. And this is just an application which is different from our context. Okay, so I have the squares. Let me squares need 1 4 9 16. Okay, square number of square elements in a list, and I want to find the mean of this square function. What do? I'll just declare one more list, or I'll just declare a variable. Okay, let me say sum of squares. Okay, first of all sum of squares, then I'll be storing the sum of squares. Fine. And this will usually take the sum of all the elements and it will be storing in sum. Okay, that will be a single value. I hope that is 20 to 30. Okay, 30 will be stored in some squares. Okay, that means sum of the squares will be 30. Fine. After that, if my aim is to find the mean. Okay, after that you have to find the length also. So I hope we have length function. So length equals to len function, right? So len of squares will give you the length. Fine. After that, to find the average or mean value, mean equals to sum, that means your sum of all the elements, that means sum squares here, sum of all the elements divided by the length. Okay, that's how you can find the mean. And let me print the mean and show you. Fine, you got 7.5, that's the mean of the square values. But here in NumPy, how I'm going to rectify, if you want to find the mean, you don't need to actually write this code and all, right? Let me go to this again. This is very simple, but if you have a lot of elements, this will be taking too much time. And if you want to analyze the value, let me have, we have the square list there, right? So let me typecast into a NumPy list. So I'll be saying np squares, okay, np slash square, so that it will not be throwing any error. Okay, now it is in my NumPy format. Okay, how to do that? I'll be say numpy dot arrays, and inside that I have to pass squares. That's it. That will be typecasting squares as a NumPy array. Fine. So if I say NumPy dot array, I'll be confusing here. I hope I'll just leave this and I'll say squares 1. Okay, so what I'm doing here is I'm just taking a list and I'm passing it in the function numpy array, so that it will be converting my list as a numpy array. Fine. And again, let me execute this and I'll show how it will be looking like. So squares 1. So that's how a numpy array look like, right? So 1, 4, 9, 16 is now a numpy array, right? So for this you can easily find the mean, right? So squares, I'll be saying numpy dot mean squares 1. Fine. That's how you got 7.5 there. You don't need to write this code. Okay, so just the idea is convert the list into an numpy array and use the mean function there. Awesome, right? So that's how it works. Okay, wait. Okay, you may be thinking, wait, bro, and this code is also easy for me, right? Why do you want me to convert it as a numpy array and print the mean? Okay, and print the mean. Use the mean function. Use the mean function inside the numpy library to print the mean. This code is pretty simple for me. You may be asking. Okay, mean is very simple because it's the idea that is sum of squares divided by length. What about standard deviation? We have that concept there, right? We have a concept called standard deviation in probability, right? Fine. So you have to know the formula and you have to compute that, right? And that's also very simple, but you have to know the formula. But NumPy will do it for you. So NumPy dot put std, that stands for standard deviation mean squares 1. Yeah, that will print the standard deviation for you. That's it. So even this one line code, you can easily print the standard deviation. That's the powerful like tools available in NumPy. Fine. So yeah, that's squares 1, but we are talking about x, our original NumPy array. That's actually x. Okay, not square. That's just for an example. I took a list and I'll just show you the usage of NumPy. So I'll be printing the standard deviation of x. That's 2.58. You can see we got the exact standard deviation value, right? Fine. So that's how you can use the library. We have standard deviation here. Fine, in NumPy library, I hope. And we can actually use some more also. Okay, let me talk. That's how you can use the standard probability statistic stuffs like standard deviation and mean. Okay, you don't need to write the formulas. You can easily calculate using the inbuilt functions. Thank you. In our next class, let me talk about the some of the matrix algebra. Okay, matrix algebraic stuff. It's high time that we should talk about that. Thank you. Hello guys, so let me welcome you to this videos or lecture. So NumPy 3, that's my third code. I have already imported NumPy library for you, so import NumPy as NumPy, so np, sorry. And yeah, again I missed to tell you one thing. NumPy stands for numerical Python. Sorry, I missed to tell you. I hope will not be angry with me. That's okay. And let me create a next an array. In this video we are going to do the matrix computation. Like you have to add two matrix, you have to multiply two matrix, like in using NumPy. If you want to, let us assume you want to write a code to add two matrix. Okay, think of like that. Okay, if you want to write a code to add two matrix, it's actually not pretty easy, right? Because you have to add each and every element parallelly, right? So if you have a matrix there and if you have another matrix here, you have to create two matrix and you have to use a for loop. Okay, you have to use a for loop for accessing elements, iterating over the columns and rows. You have to add all the elements, okay? Because the problem is you have to add the elements individually, right? That's the problem. But NumPy has standard functions that will do it for you, right? So it's a powerful library, to be honest. Like you have 1 comma 2 comma 3. Let's assume that we have a matrix. So 4 comma 5 comma 6. Fine, let me have one more. I usually like three-dimensional matrix. That's why I'm creating 3 comma 3. That's it. You can create any matrix of any dimensions. Okay. I think you have to nested list there. Wait. Sorry. Yeah, it works. So print x. Yeah, that's how x looks like. No doubts. I'll be printing x. Fine. That's a matrix. Three-dimensional. I'll be create one more matrix. Time being, let me do it quickly. Array. Fine. So that's 10 comma 20 comma 30 and 4 comma 40 comma 50 comma 60. You can use any numbers, random numbers you can use. Timing, I'm using just continuous sort of numbers, right? Just have a relation numbers, right? Fine. So sorry guys, I have to put the outer list, right? I usually forgot that. Sorry. Super. Let me print y. You got y also. So my first operation is to add these two add these two matrices. Okay, so for that I'm just saying the command markdown would be better. So markdown, adding two matrices. Fine, adding two matrices. Again, I'll upload this notebook and you can actually see that if you have any doubts. Okay, that's pretty simple. You'll say x dot add, no, not x, you say numpy dot add. In this you have to pass the two matrices. That's it. You can, it's pretty simple guys, that's it. Okay, so x is one matrix and y is another matrix. You have to pass these two matrices, those two numpy arrays in this add methods. You have a method called as add inside the np library. Np is very numpy, right? Okay, fine. So yeah, you can see we got the resultant matrix. That's the addition of two matrix, because you will be getting the resultant matrix only. Say for an example, 1 will be added to 10, result will be 11. 2 will be added to 20, result will be 22. That's how you can add matrices, right? I assume that you know. Okay, so that's how it added the matrix for us. We can actually print this to remove this comma and array and all. That's just for our understanding, right? So that's how you can get the resultant matrix if you want to add two matrices. Is it possible to multiply two matrices? Yeah, for that you have to use dot. Okay, so there is something called as dot that will give you the dot product. That's nothing but the matrix multiplication, right? So np dot np dot. Okay, don't confuse x comma y. That will be, this is the resultant matrix when I multiply x and y. So you have x here, you have y here, you have multiply x and y, and this is pretty confusing in mathematics, right? You can, yeah, when you have to multiply two matrices, you have to multiply row and column wise. It's pretty you know not easy for a beginner, right? So that's how we can easily do that here in numpy, the np dot x comma y, that will do it for you. Fine, that's another matrix operation that you can do. Okay, basics. Okay, fine. And I have one interesting function also. Have you heard of, before that I'll just create a markdown here, or I'll just create multiplying two matrices. Okay, so that you can it will be readable when you use this notebook, when you see this notebook. Fine, so multiplying two matrices. I have one interesting function there. Let me use this. I'll call this as, what if I want to get a transpose of a matrix? Fine, and transpose of a matrix. Fine, so that's pretty simple guys. Actually that's actually you have to use an again you have to use one inbuilt method called as transport, which is available in NumPy library. And if you want to access more and more methods, if you want to get to know about methods, you can actually go to the NumPy website, study the documentation that will be showing that for you, right? It's np.transpose, and here you have to pass only one matrix, because you can take transpose for only one matrix, right? It is not it is meaningless to pass two matrices. If you want to add or multiply, you can pass two matrices. Here you are getting only the transpose, so pass only x. Let me pass only x for a while. Okay, so that will return the transpose. That you can see. Let me print this. That will be getting rid of this commas and the array keyword. So that's how your matrix look like. Original matrix. Let me print the original matrix also we can understand the difference. Right? That's how transpose looks like. You can see you can get 1, 2, 3, 4, 5, 6, 7, 8, 9, as the columns here. That's 1 2 3 4 5 6 and 7 8 you mean the rows became columns and column became row. That's what we mean by transpose, right? Just taking inverse. Okay, rows become column and column become row. I assume that you know what is transpose. So let me move on to the next content. Fine. We have one more interesting function, guys. It's called zeros, creating zeros and rows, zeros and ones. Okay, that's the spelling is actually, I think this is the spelling, but here we don't use e. We have only zeros. You please stick with that, and I'll be taking it as a markdown. Okay, creating zeros and ones. So how to create zeros and ones? Fine. So what do you mean by zeros and ones, to be honest? Okay, so if I say zeros, I want to create matrix of my own dimensions that will have only zeros in all the rows and all the columns, that will be having only zeros. It is possible, yeah. For that, let me create one more variable, say z, that will be having that zero matrix. Okay, so np dot array, let me create zeros first, and after that I'll be teaching you how to create one. So np dot array, and np dot array, and I think not array, it is zeros, so zeros, np dot zeros, you have to use that, and inside this you have to pass as a tuple pair as a dimension of the matrix. Okay, you have to pass the dimensions of the matrix. Let me say I want to create a 3 by 3 matrix. Usually I go with 3 by 3, right? So 3 by 3, that's it. Yeah, you got that, and we'll say print z. Fine. We can see B got a 3 by 3 matrix. Every column, every element is filled with zeros only, and you can see we got 0 dot there, that represents that it has a float value. Okay, fine. Okay, it's a float value, guys. Okay, we want to, okay. How do you find whether it is a float value? It's pretty simple. You just put type of any one element, right? So zero, I have to print the type of 0th row and 0th element. Okay, we can see we got float 64, and that's an Numpy data type available. So you can get it as a float value. Do you want to get it as an integer? No doubts. It's not tough. You go to this, and you have to pass one more argument called as d type, stands for data type. Pass integer here. That's it. You print z again. You can see we got integers, and you have to print the z, and you can see it prints int 32. That's how we can print integers. Fine. Any data is possible. You can also print string. Okay. You will be having one more data type also, some interesting stuff called as complex. Okay, that's a complex number. Okay, again it's a float value, real part and imaginary part. Okay, so you print every zeros in terms of complex number. That's how data type works. That's an argument that you can optionally pass. Okay, that's optional. By default it is set as float, but you can optionally make it as int or complex. Okay, so you can see we got complex 128. Fine, that's complex number. I assume that you know about complex numbers. Fine, so super. Let me declare one more, say a, that's one more array, np dot ones. Okay, let me create matrices of which all the elements filled with only ones. Let me create 2 by 2 matrix time being. So yeah, let me print a. So you have to put numpy dot one. So you can see we got output, everything is filled with ones, and the data type is also possible here. D type, say int print a. You can see we got all the elements filled with ones. That's how we can create zeros and ones. That means you can create a matrix. Okay, you can create a matrix. You can initialize the values with zeros or ones. That's your wish. Okay, you can initialize the values, and this is the point I want to insist. You can actually initialize the values. Okay, this is very important in data science. Okay, you know how to create, you should know how to create a matrix and how to initialize the values. Okay, so zeros, and every element is initialized with zeros here. Fine, that's how it works. In our next lecture, let's talk further on this. Thank you. Hey guys, welcome back. So in this class, let me tell you how to iterate through the NumPy arrays through simple methods. Okay, we have some default methods available for that also, right? We are going to see that. For that, let me use X itself. Okay, X, we have a lot of elements, right? So I'm using the same notebook. So my topic is actually iterating through the elements. Okay, the array elements. Fine, when I say array, it's a matrix. Fine, here, two-dimensional array. Wait, and we actually have two ways. Either you can go for nested for loop, right? You can go for nested for loops. Wait a minute, I need to write it here. So you can go for nested for loops. I think this should be put in this subtopic. This is a topic and this is subtopic. Yeah, that's how it looks. Okay. And you can go for a method which is available, and I'm going to tell you about that. Okay, let me complete this video quick. nd iter. Okay, so iter stands for iteration, so or iteration or anything. So nd iter, we have something like that, and I'll tell you how to use that. Okay, so some very basic functions available. So it's a function actually, so I'll do this. Let me give respect to that. Okay, so that's how you can iterating through the array elements. You have two methods. Wait a minute. So I think it's no, I'll use header here, heading. Okay, no problem. So okay, we got nested for loops and nd inter. So first of all, let me use nested for loops. Okay, so let me use nested for loops, which means how to iterate to every element. So we got you can see we got x here. We have x of x. We have a lot of elements. So how to iterate? It's pretty simple. You may be knowing this. For I in range of, wait a minute, for I in x, fine. That's it. Okay, fine. I in x. That means I will now take the x is nothing but the umpire is. So let me print I and show it for you. Let me print I. Execute this. You can see we got single row. Okay, so this will, if I say for I in x, it will be getting the single row. Okay, so I will now have 1 comma 2 comma 3. After the iteration, the second iteration, I will be having 4 comma 5 comma 6, and that is getting printed in every iteration. So I will be iterating over rows. That's pretty simple. Fine, but I have to get the each and every element as separate as a separate element. Okay, each and every element as in separate lines. For that, I have to use one more for loop, right? I hope so. For j in I, for j in I, print j. I'll tell you, I'll explain you. I hope you know that. Okay, so you got every element in a single line. That means for I in next, let me say I'm in first iteration, 1 comma 2 comma 3, right? That's my first iteration. So I assume that you study the first iteration. So I will now have the value 1 comma 2 comma 3. From x, I will take the first row. So that is 1 comma 2 comma 3 now. Okay, so from 1 comma, I will have 1 comma 2 comma 3 now. From 1 comma 2 comma 3, you have to take one value. So j will take one value, j1, and that will be printed. Again j will take another value 2, and that will be getting printed. Okay, again j will take the last element, that is 3, and that will be printed. After that, the control goes to the outer for loop, that I will be having the next row, that is 4 comma 5 comma 6, and j will be taking each values and will printing it as 4 5 6. That's how we can use nested for loops. I hope you understood this. I hope you know this already, so no problems. That's why we put this nested for loop. But instead of writing two for loops, nested for loop, you actually have a function in NumPy called as nd iter. So you can use that. So I'll say for x in for I in, okay, let me not confuse you. For I in np dot nd iter, I'll pass x here. Fine. So let me print I. That's it, you got same output, right? So you just pass the numpy array in the function nd iter, so you iterate over I. That's you'll be getting all the elements line by line. Fine, that's how you can use the standard libraries available in it. It's moving on from the classical code. You have to know how to write the code, but it's high time that we should move on from classical code to the standard libraries available. You have to make use of that. That's the objective of this course. Fine, so yeah, let's talk further on the next video. Thank you. Hello. Hey guys, I welcome you all. So in this lecture, let me quickly finish off the matrix algebraic concepts, so that we can move on to differential calculus SymPy library by using some functions called as concatenate, arrange, and arrange and reshape. Okay, let me use that functions. I will finish it off with that. So concatenate a matrix, to be honest, concatenate a matrix to another matrix, or concatenating two matrices. Before that, okay, concatenating two matrices. After that, I'll tell you how to concatenate a row. That's pretty simple. Okay, concatenating two matrices. I think I have the two matrices in this code in the previous video, x and y. Yeah, to add these two matrices, I used that actually. Yeah, x and y, I have that here. no problem. So let me concatenate these two. Concatenating is different from adding. Okay, so when I say adding, when I say adding, it is actually, yeah, it is actually adding each and every element. So you have to use add function to add each and 1, 10, 2, 20 and all. You have to add all the elements. But concatenating is not like that. Okay, you have to concatenate. Let me tell you, you have to attach these two. Attaching. Okay, think of that. That's fine. Pretty simple. Let me say np dot concatenate. Okay, and you have to pass it as a tuple pair. You have to pass your two matrices as a tuple pair, otherwise it will definitely throw you an error. Okay, so tuple pair, so you have to put inside this parenthesis, you have to put one more parenthesis, and I have to pass x comma y. I assume that you know tuples, so yeah, that's how we can concatenate that. That means these two matrices are now a single matrix. Okay, which all the rows, let me print this and so that you'll be getting an idea. Fine, you can see we got this is a matrix which is 3 by 3. This is also a 3 by 3 matrix, but here we got actually 6 by 3 matrix. This is, these three rows are actually attached to the previous row. These two rows are bundled and you are given as a single matrix. That's how we can concatenate. Fine, so you got a single matrix there, and then question arises, I can, you got 6 rows and 3 columns. Fine, that means you got 3 rows 3 columns here, you got 3 rows and 3 columns here, and you concatenate these two, you got 6 rows because you are concatenated the rows. Okay, you have concatenated the rows. Fine, 3 rows and 3 rows getting adding up to each other become 6 rows. Is it possible to concatenate the columns? Fine, so because say for an example, instead of getting 6 rows and 3 columns, I have to get 3 rows and 6 columns. Okay, is it possible? That's pretty simple. Let me print it here. So print np dot, wait a minute, np dot concatenate x comma y, and after that I have to pass axis, and that should be made as 1. Okay, axis represents x or y axis, so my column is actually y axis. Think of like that. So x is 0 and a row is actually 0th axis, and the column is the first axis. So axis is 1 represents y axis, and x axis represents row, y axis represents column, and axis is 1. Let me assume that I think yeah, you have to pass it as a tuple pair. I told you, right? So you have to pass it as a tuple pair. I think you have to include axis in this. Fine, include axis in the concatenation itself. Fine, so inside concatenate function you have to pass x comma y as a tuple pair, and you have to pass axis also. Fine, yeah, you can see we got something like this, which means our our rows and our elements of the second matrix is concatenated in the column wise, the row wise. Fine, this is actually column wise because you're getting 6 columns here. Okay, okay, let me print the size of this. For that, let me store it in some variable, say array1. Fine, okay, I'll be storing it in this is some variable, say array2. Fine, let me execute these two. Fine, so let me print the shape, array1 dot shape. You got 6 comma 3. Wait a minute, yeah, 6 rows and 3 columns. That's correct, I hope. So array dot shape to it's 3 comma 6. That's 3 rows and 6 columns. So you can concatenate 3 rows in a 3 by 3 matrix with you can concatenate the rows. So you'll be getting these two matrices will be attached as it is. So you'll be getting 6 comma 3 shape, and these two matrices will be attached column wise. So you'll be getting 3 comma 6. You can concatenate by giving an axis parameter. Okay, so that's possible. Fine, super. Let me talk about one more function called as two more functions called as arrange. Fine, so what do you mean by arrange? It's not arrange, it's arrange. Okay, you can see r is missing, which means arrange stands for arrange. Okay, generating a range. Okay, it's very common to the I'm sorry, wait a minute, it's pretty common to the range function we have. When I say range, it will generate a range of numbers, right? So it's pretty common to that. Fine, so but here it's called as arrange. So let me talk about that now. So let me talk about arrange. So it's pretty simple. Let me say numpy dot arrange. Okay, the parameters are, you have to put a it's very similar to range. You have to put the start value, stop value, and a step value. Step value is actually optional. Everything is optional, I hope so. But start value, okay, let me step value, the end value is important, I hope, because you should know how to end this. So let me create an range of 1 comma 5 or 1 comma 6, okay, 1 comma 6, and let's check what happens. So you got an numpy array which starts from 1, and you know that we actually talked about that in the previous video. It doesn't go up to 6, it goes up to 5 only. So you got up to 5. That's how you can generate a numpy matrix with array function. That's one dimensional matrix, to be honest. Okay, so numpy dot arrange 1 comma 6. Yeah, I have to this is increased in steps of 1, right? So 1 plus 1 2, 2 plus 1 3. Let me increase in steps of 2. So I got 1 3 5, which means 1, start from 1, add 2 in that, you'll get 3, because that's 2 step value. Fine. So again add 2 in that, you'll get 5, and after that add 2, goes to 7, and that is out of range because it should go up to 6. That's why you got 1 comma 3 comma 5 that, right? So you can actually have some optional parameters also. So let me print that for you. Orange, so sorry, it's single r, remember this. So 1 comma 6 comma 2, data type, let me change data type as d type, say complex, getting complex numbers. Yeah, that's how we can get complex numbers. Okay, that's the beauty of numpy. Fine. So that's how arrange works. Fine. That's all, guys. So in the previous lectures we have what we have seen, let me summarize quickly in just a minute. Okay, so we have seen how to create a matrix, how to do matrix algebra in numpy. So we have been exposed to create how to create a matrix, access elements, rows, columns, slicing. So slicing is something typical here, not typical, something to be understood here. And after that we have seen some inbuilt functions or methods which are available inside numpy library, and you have a lot of methods, trust me. Go and explore in numpy documentation. I hope you got an idea about numpy library now. So this is the base for data science, and you can actually now start learning the I know the concepts of data science, because you are now very strong in numpy. Okay, so yeah, numpy, some max minimum, you have to use that. Okay, so the standard deviation minimum and dot and add and all, you'll be using that. And you have one more function, and I'll leave that to you, called as reshape. Okay, and that will reshape the shape means there's nothing but dimension of a matrix, right? So reshape will actually reshape the matrix. So go and explore that and check how that works. Fine, and I'll leave that for you. And in our next module, let us talk about Sympy library, which is available in Python to do some exciting stuff like differential calculus, integral. Rather than matrix algebra, let's move on to calculus. Fine, see that. Hey guys, moving on. So in this video we're gonna learn how to compute linear equations, or linear equation with one unknown, two linear equations with two unknown. After that we'll move on, we'll see about quadratic equations, how to solve quadratic equations using Python, and we'll integrate some standard functions, differentiate some functions, and differentiate off with that. Okay, for all these mathematical computations, these are it depends upon the application that these modules are actually, these functions are actually used in data science. Depends upon the application, but it needs for mathematics. Okay, so data science is, machine learning is all about mathematics. For that you have to know all these steps in mathematics. Fine, super. So for that I'll do one thing. I'll just make it as markdown, and here I'll put like this. Let's say the operations I'm gonna perform. Okay, basically the problems. First of all, I'm gonna solve a linear equation with one unknown. Okay, linear equations with one unknown. Fine, wait a minute. uh, just linear equation with one unknown. After that I'm gonna solve I just copy this, sorry. I just pasted instead of copying. So linear equation with two unknowns. Okay, two unknowns. When I say unknown, please understand that it's all about x and y's you have. When I say one unknown, I have only one unknown variable there, say x. I want to find the value of x, that's it. And you may be knowing it already, I assume that. And solve quadratic equation, let me say quadratic equation, you have to factorize this and solve that, right? And you also have a formula to solve that, like minus b root of b square minus 4ac divided by 2a. This algorithm actually works like that, and you no need to worry about that, and we have an inbuilt function and that will do it for you, right? So after that we're going to solve yeah, we have to integrate and differentiate, right? So we are going to integrate and you're going to differentiate. Fine, super. So these are the operations that we are going to do, and I think here it is. Yeah, this should look something good. So yeah, so after that, if time permits, we'll do some other operations like permutation and combination also. That's very simple. You don't need to import any sympy. You have a inbuilt function in Python itself. So for this, let me import. Okay, let me please follow me. I'm gonna solve an equation like say for an example, I'll have an so I'll just mark down. Okay, the equation, the first operation I'm going to do is I'm solve linear equation with one unknown. So what do you mean by that? Let's take an example. Let me say I'll say x plus 6 minus 9 equals to 0. Like this, I have just a linear equation with just only one unknown. Okay, so if you have like that, I'll write a multi-line comment to be honest. So I can do this code. Notes. Okay, so x plus 6 minus 9 equals to 0. So what will be the output? Just guess the output. It will be it should print x plus 6, so it should compute like this, right? X minus 3 equals 0, because plus 6 minus 9 will become minus 3, so x minus becomes minus 6, negative 3 becomes 0, and after that x equals to 3 if you take the negative 3 to the right hand side. So the value of x is 3. Like that you have to compute. Okay, so this expression should be given to the inbuilt function, and it should compute the value of x for you. Fine. So the variable can be any alphabet. It need not be x. It can be y also. For example, if I have y minus 9 into 10 is equals to 0, then I have to do that y minus 90 equals to 0, then y equals to 90. That's the value of y there. So I can code a lot of you know examples like this may look simple, but this is the basic thing. Okay, and we are see the course name, we are looking at the basics now. Okay, so Python basics for mathematics and data science, and yeah, that's how you can solve a linear equation. But here an important thing to remember that you you know there is no need for you to put equals to 0. Okay, when you take it as an equation, it will assume it for you that is actually equals to 0. Okay, say for an example, if you want to calculate this expression, you just have to pass it as x plus 6 minus 9. It will do it for you. Okay, so it will calculate it for you. You know, please don't mention it equals to 0. It will be giving you an error, I hope. Okay, so that's the another point I want to insist. Okay, need not put equals to 0. Okay, need not put equals to 0. Fine, it's actually the meaning is it is equal to 0, but you need not put that. Okay, it equals 0. That's the equation. The word equation says that something is equated to something, it's equated to 0, but you need not put. Python assumes that. Okay, fine, that's the point I want to insist. Super. Leave that. No need that for now. Leave that. Okay, just a comment. Fine, super. Let's import. Okay, the first will be importing the library, right? So let's say from. I hope you know the from keyword. If you say from, you have it's straightforward. It's pretty straightforward. You from that particular module, you import some functions. Okay, functions or objects or classes. You can import anything from that particular module. Fine. So from Sympy, you have to import. I hope you have installed Sympy in the starting of the course. Okay, we have installed that. No problem. So from Sympy, import symbols. I'll tell you what are symbols. Okay, you have to import symbols first, then solve. There is a function called solve. You have to import that also. After that, you have to import equation. I think equation is not necessary. We'll leave that. Okay, let us import these two, symbols and solve. Fine. Okay, again, symbols is a class. You have to create an object of that. If you don't know what are classes and objects in Python, you can go back and search for my course on my instructor profile. There will be a course called Object Oriented Programming in Python, and there you will get everything about classes and objects. And I've explained some concepts related to movies. Okay, so you can actually enjoy that. Fine. So from Sympy, import symbols and solve. So let me say x equals to symbols. Okay, so So yeah, whenever you have a class, you have to instantiate that, right? So symbols is a class. I have to create an object like this. Fine. So yeah, x equals symbols. If you put like that, it means you are creating an object. And this symbols, keyword is basically to declare your symbols that you are declare a variable that you are going to use. It means that it is your say for an example, if you want to calculate this expression, you are naming the unknown as x. Fine. Again, I'm repeating. If you want to calculate this expression, you are naming the unknown as x. Here, you are naming the unknown as y. So you have to inform the you have to make these as symbols. Okay, you have to import make x and y as symbols. That's pretty simple. That's pretty simple. I'll say. Let me remove this. I'll say in this inside the symbols parentheses, I have to pass x. That's it. Then x will now become a symbol for me. Fine. So let me for easier calculation, let me assign it to x itself. Okay. So this will now work. So that's how we can create symbols. Okay. So if you want to create a symbol, you have to put that in at the first declaration itself. We have to put that in inside this parenthesis, and that should be stored somewhere. I'll store it in x so that it will not confuse you. Okay. So if you can also create one more symbol. I'll talk about that in the next video. Okay, when you're solving two unknowns. Okay, fine. That's how you can create symbol. Now x will have the symbol x. Fine. X will have the symbol x, so you can use x now. Fine. Super. So to solve the equation, you have to use solve. Okay, say solve. You have to give the expression here. Say I'll just solve this x plus 6 minus 9. So I'll put here x plus 6 minus 9. So simply if you put x, if it won't allow, you should have already declared it as symbol. Okay. So say for an example, yeah, it would have executed, right? So I'll do that. Okay, fine. So I'll solve this. Yeah, you got 3, right? So because you know x equals to 3, okay, it returns as a list because you can have a multiple values there. So no, not here. In some cases you may have multiple values, so it returns as a list. So you can see we got the output. Okay, it's solved. Okay, let me solve our second expression too. For that you will say solve y minus 9 into 10. It will throw in error. I'll tell you. Okay, so say name y is not defined, and you have to define y as a symbol here. So either you can define like this. Okay, you can define like this. You can put one more y. You can do like this, or else this is something verbose, right? So I can remove, can do like this. This is also possible. So let me comment this. Fine. Here itself you can put a space, put y here, and comma y. So it's inside this is not comma, it splits like a space. I think the inbuilt library. So put it as a space, give some space and put y there, and here I have to put y. Okay, let me run this code, and now run this. It will definitely work. You can see we got the output 90. Fine, because y minus 90. You can see we have not put z equals to 0 here. Not put equal to 0. It's actually equivalent to x minus or x plus 6 minus 9 equals to 0. But we have neglected that equals to 0 because by default it assumes that it equals to 0 because you are saying solve, right? So it equals to 0. After that it computes the value of x, and here also it computes the value of y. Like this you can calculate some complicated expressions also using this Sympy. So it will be helpful for your projects if you are developing simple projects in Python. Fine. So that's how it Sympy works. Fine. So in our next video I'll tell you how to solve linear equation with two unknowns. Thank you. Hey dudes, welcome back. So in this video, let's solve a linear equation with two unknowns. Before that, I'll just copy this. And I'll paste it here. Let's create a topic here also. Markdown. Fine. So yeah, you're gonna solve linear equation with two unknowns here. So that's also pretty simple. Okay, I've imported everything. I hope I imported symbols and solve. So that's simple. We are going to use same symbols and solve. That's perfectly fine. And I hope we have to create a new notebook. So we have it may not confuse you. It may confuse us because the point here is we are using x y here also, and if you use x y in this equation also you are going to use x and y. So that may confuse you. So let us create a new notebook, and it will not take much time. I hope. Just 2 minutes. Give me 2 minutes. I'll do that for you. So. Okay, that's the topic we have. So from Sympy, okay, let's import from Sympy, import symbols solve, and you have to import one more function called as equation, okay, or class, okay, I don't know, it may be a class or function, you can import anything, so that's equation. So eq, that's you have to import because you are going to use two equations, right? So we have to import that. Fine. So symbols is very easy, so let's use our symbols, and I'm going to solve these two equations. Say 3x plus 2y, wait a minute, 3x, wait a minute, okay, I'll just write a multi-line command so it won't disturb me. So 3x plus 2y equals to 5, okay, and I'm going to solve one more equation called as 6x plus 7y equals to 10, okay. I don't think so you get the integer values, you may be getting something different. Okay, let's leave this. We have to solve these two equations, okay, that's it. Fine. So for that, so we have to solve these two equations. That's it's not equal to 0, please note that. And because since we have two unknowns, we have two equations, so it's just like using elimination method. You have to eliminate values and you have to solve it. It's manually you can easily solve these equations, right? Find the values of x and y. How Python is going to do that? Okay, for that, first step would be taking 5 and 10 left hand side, okay. You have to assume, because Python assumes that this equation is equal to 0, so you have to make way for it. Fine. So let me do that. So 3x, I'll just copy this, okay, I'll just copy this and take 5 and 10 out the other side. So from this I'll put 5 equals to 0, and here put minus 10 equals to 0. Because why we are doing this, because Python assumes that our equation is actually equals to 0. We are not actually mentioning that. So if you have any constant term, that please bring that back into the left hand side, so so that Python works correctly. Fine. So that's how you can create some in this video we are going to solve this two equation. You can solve any two equation, that depends upon you, okay, but I'm going to take these two equations. Fine. And I actually don't know the solution for these two equations. I wrote an equation, okay. Fine. First of all, let us create the symbols. That's the first step you have to do. So I'll say symbols, okay, symbols x comma y, or not x space y, and you have to store it in x comma y, right? It's a tuple, to be written as a tuple, and x will have x and y will have y. Okay, fine. That's the first step you have to do. And now an extra step would be there, because you are solving two linear equations with two unknowns, so you have to create the equation also. So let me say to create an equation, you have to use the equation function. We have imported that, okay. I don't know, maybe it's a class, okay. So class, you have to instantiate the class. So equation class, maybe I could create an equation class here, so equation object here, okay. So I'll just put here, I'll say 3 multiplied with x. Don't put 3x, it won't accept, so you have to put 3 multiplied with x, 2 multiplied with y. I'm putting this to 3x plus 2y, and minus 5, and I have to store this. I have to instantiate the class with an object called as equation 1. And if you don't know what is called instantiation, just go back and watch my object oriented programming lectures, okay. So equation, and again I have to pass this also, and yeah, we have to pass that. You can see we have not putting equals to 0 anything, so we are just putting these, okay. Fine. So this into, okay, so yeah, that's how you can create equation 1 and equation 2. This is just a depreciation bonding, okay, or just default to 0, okay. That's not a problem here. Fine. If you want, you can actually make RHS here. If you want to RHS to be some value, just put comma and you can give the value. Fine. For example, by default it assumes a 0, but if you want to use this equation, just put 3 into x plus 2 into y and pass comma, you pass 5, okay. That will be taken as right hand side argument. Fine. But we don't have right hand side argument here, just zeros. Fine. So let's leave this, okay. Let's stick with 1 and leave everything, okay. Fine. Okay, this will work. Okay, equation 1 and equation 2, just put solve equation 1 and equation 2, okay. Use solve function to and pass these two objects, equation 1 and equation 2. That's it. I think wait, let me pass it as tuple pair. I hope, oh sorry, yeah. you have to pass that equation as two equations as a tuple pair so that it returns something, and it says value of x is pi by 3 and value of y is 0. I don't know whether it is correct or not. It is actually correct. Actually, Python you know uh, don't do wrong things, right? So it's actually correct. So that's how we can solve two linear equations. Okay, so the first step would be importing the modules, then creating the symbols xy. Stick with xy. You can give anything a and b. That's your wish. And after that, you just create the equations. Fine, you just create the equations. After the, I mean, create equation objects, equation 1 and equation 2, and put those objects as a tuple pair. You can see we have two brackets there, so tuple pair inside the solve function that will fetch the value, and that returns the value as a dictionary. Please note this, okay? Key value pair. So I can actually store this in a dictionary. Okay, so I can, using this I can use my indexing. I assume that you know dictionary, so I'll just say what's the value of x, I say like that, and it gives 5 by 3, and I'll say what's the value of y, it gives 0. Like this you can do something, and you can do anything here. It's actually possible. That's how we can solve linear equation with two unknowns. Fine, thank you. Hey guys, so in this video, let's quickly I'll tell how to solve quadratic equations. So what is the structure of quadratic equations? That will be polynomial. To be honest, when I say equal to 0, it becomes an equation. So polynomial equation. Okay, so I'll say x square, so I'll put x power 2, and if I put 2 asterisk, that's power u. I assume you know that. So x square plus 5x 5 into x plus minus 6 equals to 0, and that's a quadratic equation, right? So you should know how to solve this using Python. Okay, so even if you have any doubts in your homework, you can actually use Python code to get you the answers, and x power 3, and I think it's you can use that. You can use x power 3 also. Even that's not quadratic, it's cubic equation. You can solve this, I hope. So let's try. Okay, and first step would be definitely creating the symbol. So I need only one symbol, understand that, because I'm going to solve quadratic equation. So I'm going to have only one symbol, but two values, right? Fine, symbols. Okay, I'm sorry, symbols. Two values, one symbol with two values, because it's x power 2, so you will get two values, two solutions, or two roots for the quadratic polynomial. So we're going to find the roots of the polynomial. Fine, so yeah, let's solve this. So solve, no need of creating any equation. You can do that, but you can directly go solve and get the answer. Fine, so solve, I'll say x power 2 plus x power 2 plus that means x square plus 5 into x plus 6. That's it. Okay, minus 6. Okay, and need not put equal to 0 because it assumes you know that. Fine, okay, the answer is minus 6 comma 1. The point here is it returns the answer as a list. Okay, so the list may contain only two elements because you are raising the x power, the degree is 2. Okay, so it raises two elements. If I say x of let me store it in somewhere. Let me store this in answer. Fine, so I'll say answer of 0, that will give only one root, and answer of 1 gives you the another root also. So what is the type of answer of 0? Basically, it's isn't it, is it an integer? Let's check. Okay, it says sympy.co.numbers.integer. It's actually an integer, but this minus 6 belongs to something called a core of sympy, so that you will get some enhanced look here. You can see that this is a different, that is the difference between printing normal integers. I'll show you the difference. Let's say a equals to 5. Fine, I'll a, yeah, you can see the size. Okay, so minus 6 is something broader, and just an integer is 5. That's why my answer belongs to something called as sympy core. Okay, that it belongs to that. Okay, returns in that, and you can typecast it as an integer, but that's your wish. It's all actually an integer but belongs to some library. Fine, it's not a default integer. That's why you get some enhanced look there. Okay, okay, that's fine. That's how we can solve a quadratic equation. Let me solve the cubic equation also. Let's check whether it works or not. Okay, I don't know. Fine, let's copy the same, and let me add one thing, x power 3, so that it works. Fine, so I have to add one more term for x power 3. So let me say x power 3 plus, I'll multiply this term with 10 so that it works or not. Okay, 10. Fine, okay, let's check what happens. I'm gonna solve this is a cubic equation. Okay, just write it in a paper if you don't understand what I've written. Okay, cubic equation, x cube plus 10x square plus 5x minus 6 equals to 0. Fine, let's solve this. Yeah, you got the answer, but that's a different answer because I think this doesn't solve correctly. You got some weird answers, but this is the correct answer, I hope. Okay, this is the correct answer for this cubic equation. You can solve cubic equations, okay, but you got some weird answers here. Yeah, that's because of the equation structure we have provided. Okay, if you simply give the equation that is easy to solve, that will give you the definite answer for you. And this is the equation that we have framed somewhat, which is not relevant, I hope. The terms are not connected, that's why it gives some weird answers like this, but this is the correct answer for this equation. You won't believe that. Fine. So, okay, in the next video let's actually go to differentiate and integrate you know uh, functions using this Sympy library. Thank you. Hey guys, I hope that I have introduced a lot of new concepts for you. So let's finish it off with this concept called as integration and differentiation using Sympy library. So this will be very helpful for you to develop a project. And in our next course, my course named GUI projects, we will develop some interesting applications, or Kiwi, where I'll be teaching you Kiwi framework. You can actually enroll in that. You can develop your mobile apps in Python. Okay, again, don't think that that app will be looking like something developed in Android Studio, but it's better. Okay, you can use this function. You can develop a mobile app that will integrate and differentiate for you. Sounds good, right? So we'll do that. We'll do that in next course. We'll do our hands-on project. Okay, so please wait for that course, and let's come back here and check what happens when you integrate and differentiate. Super. So differentiate and integration, it's very simple. From Sympy, again, from Sympy you import some functions like a diff and integrate. Of course you should have symbols, I hope. No need of symbols, let's avoid that. Just import diff and integrate. That will work, I hope. I don't know, let's check. So I'll just say diff stands for differentiation. So let's differentiate an expression. Let's create the comment. You know the derivative of sin x, right? So derivative of so let me say f of x. Let me do some mathematics here. So if I say the function of x, I hope you know the basics of derivative. This course assumes that. Okay, so I'll say f of x equals to sin of x. So f dash of x would become what? F dash of x becomes cos x, right? So let us try to differentiate that. Okay, so let us try to do this. Okay, let's give our let's give sin x to the as an input to the differentiate function. Let's check whether it outputs cos x or not. Fine, I'll say difference, and let me tell you what are the arguments you have to pass. Here you have to pass, let me comment this also. So here you have to pass the expression first, the expression which you actually want to differentiate. So you have certain rules to differentiate expression, right? When you have more than one terms, you have to use the rule called as product rule. Or if you have a in the form of a by b, a fractional form, you have to use something called as quotient rule. And again, this will do everything for you. Okay, this expression, function will do everything for you. No need to worry about, just put the expression there. And after that you have to pass the symbols which you are passing. So x, so that you have to pass. So it has to basically two arguments you have to pass. One is the expression, and comma, that's the you have to say with respect, which variable should be given respect when you differentiate, right? I know basically when you're differentiating, differentiate like that, the questions will be differentiate with respect to x, right? So you have to give respect to variable, right? It should be differentiated with respect to a variables, and you have to pass the variable here. Fine. So yeah, you have to differentiate. This actually means that I'll highlight it here. This actually means that differentiate the expression, say expr here, with respect to x. You need not pass x, you can pass anything there. You can pass the expression, and if you say x, it means that differentiate the expression with respect to x. That's it. I hope you understood that. Fine. So differentiate, let me pass the expression. So that is sin of x. Let's go with a simple one, and I'll pass x. Okay, so I wanted to differentiate sin x with respect to x. Fine. Sin x with respect to x, will this work? Sin is not defined. Okay, I have to import that too. Okay, I think I have to import that. No worries. I'll say this instead of importing differentiation integration, I'll just let's import everything. Okay, let's import everything and check what happens. Fine. Okay, then this will definitely work because sin x might have present somewhere in Sympy, so this will definitely work. Let us import everything. Need not import some specific term. Import everything. And before that, I have to do one thing. I forgot that. I'm sorry. I'm really sorry for that. I have to pass the symbol, right. So yeah, I have to instantiate a symbol object, right? Symbols object actually. So x is now a symbol. How it will work? Yeah, you got cos x there. That's how it works. Okay, I'll say differentiation of. You can play with this. Okay, e power x. I think this should be put in curly braces. E power x multiplied with sin x. Okay, and put like this. Put some brackets so that it will not confuse. And after that, pass x. E is not defined. I sorry, it's expo. It's actually not e power x. It's expx. Okay, exponential of x. This should work now. You can see it is e power x sin x plus e power x cos x. That's actually work. Right. I'm sorry, it's not e power x. It's actually exponential of x. That means e power x. Okay, so exponential of x into sin x. If you differentiate that, you have to differentiate e power x first. E power x, if you differentiate it, is actually e power x. Okay, e power x plus into sin x plus again e power x should be kept constant. Sin x should be differentiated. I hope you know product rule, and I'm not explaining that here. Fine. So the answer of that will be this. Super. Then I'll differentiate one more term to be short. I'll say sin x. You can use anything here. Let me say log x. Okay. I don't know. Let me say log. I didn't try this. Okay, 1 by x. Fine. So differentiation of log x is actually 1 by x. Fine. Okay. Let me play with this. Let me say sin x. But I want it to be differentiated with respect to a. Fine. Let's check what happens. We'll say name error. Okay, I have to make symbol for that also. So I'll say x comma a, and you can pass any alphabet here. So a, it will accept. We can see we got 0 because if you differentiate sin x with respect to a, there is no a there. I assume you have math. You have some knowledge in math, so there is no a here. So that's a constant that I think treat it as a constant so that it gives 0. Okay, differentiation of any constant gives 0. For example, I'll differentiate that's 5 and I'll pass x here, that will give 0. Fine. So that's how it works. Okay, I know I hope that you guys are very so experts in this, so you can actually explore more in that. Okay, so I'm basically weak in this particular topic, so you can use your knowledge in differentiation and differentiation and integration to solve this. Okay, when I say derivative, it's something a change. Okay, a rate of change with respect to something, right? you know One variable changes with respect to another variable. That's it called when I say my day-to-day life changes with time. Okay, that's why that's it. You can take derivative and find how much it has changed. Okay, for a small change in x, what is the change in y? That is actually derivative, right? When I say dy by dx, when a small change in x, what is the change in y? Okay, for example, demand versus supply. So when a small change in demand, supply will also have some changes, right? So when demand increases, actually supply will also increase. I hope that's how it works. Okay, super. And I'll just use integration now. Okay, and when I say integration, you have two different types of integration, right? Definite and indefinite, right? So definite and indefinite. Fine. We have two different types. I'll teach you how to calculate these two, and definite and indefinite integration. Fine. Super. Instead of putting it in comment, I can actually uh, make the markdown topic here. Fine. Wait a minute. Yeah, definite and indefinite. First of all, let us see about indefinite integration, because indefinite integration is something where you don't have any limits. Okay, so where you don't have any limits, that is a simple integration symbol alone. You have to integrate. That's it. You don't have any limits. You need not substitute the limits. You have to get a function of x, not the finite value. Okay. Super. We have already created the symbols. I think we are not in need of a, so let's remove this. Or okay, let me have this. No worries. Why don't you disturb that? Because we have an expression here. Why don't you disturb that? Okay, fine. So yeah, first of all, that's very simple. You just use the integration function. Again, one more thing I forgot to tell you is you can store this value in some variable you want. Okay, let me say answer in some variable you want. You can store the value and you can use it further. Fine, super. Let me integrate this. Let integrate sin x for a while. Okay, sin x integration should be minus cos x, I hope. And here is also same. You have to pass the variable with respect to you have to which respect to which you are integrating. Fine. For example, I'll say this means when I say this integration sin x, and this means that sin x integrate sin x with respect to dx, will say, right? It is actually integral of sin x dx. Instead of dx, we will pass only x. That's it. When I say x here, assume that is dx. Okay, so you are actually integrating sin x with dx. It's like the dx in integration is like the battery in a remote control. Okay, so when you assume when you assume integration as a remote control, then dx is actually your battery. Without that, it is meaningless. Fine, it will not work. Okay, so integral of sin x dx. Fine. Yeah, it is minus cos x. You can see we got the output there. Fine. Okay, let me play with this. Let me say integrate sin x a. Fine. We got a sin x because this works in a way that you differentiate this is equivalent to integral sin x dA. Since we are differentiating, sorry, integrating with respect to dA, here the sin x will be treated as constant, and that will be taken out. Okay, that will be taken out. So you will get integral of dA. If you integrate dA, you will get a alone. So that will be a into sin x. If you don't understand this, you can that's if you don't understand this, and I would highly suggest you to get a good calculus book and study this is actually very important when you talk about machine learning. Fine, so that's it. Moving on, we can have a lot of discussions here. Let me have some complex expressions. Like you can have a lengthy expression also that will work, no doubts. Exp e power x into sin x. Fine, with respect to x. Will that work? Yeah, you got some output like this, and I think this is something. Okay, let me leave this for a while. Okay, so yeah, that's how we can calculate indefinite integration. So what we have done is nothing but indefinite integration. Let me do a definite integration for a while. Okay, so this is a definite integration. Fine. Okay, fine. So definite, and then this is indefinite, right? So let us remove this so that if I give you the notebook, I will not be confused. Fine. So definite integration. So definite integration, you have to pass the limits. That's it. So let me take sin x itself. Let me pass some limits. Okay. So integrate sin x, fine, sin x, and you have to pass the respective variable, and you have to pass I think the variable is called as uh, dependent. It's not dependent, it's independent variable, right? So you have to pass the independent variable, and that's independent variable should be passed. After that, you have to pass the lower limit and the upper limit. Okay, for our easier understanding, let's take an polynomial, say x square. If you integrate, that will be x cubed divided by 3. I'll pass 0 and 1. Okay, lower limit, upper limit. Yeah, let's check what happens. So yeah, lower limit and upper limit, you have to pass lower limit first, then you have to pass the upper limit. Okay, that it will give substitute and gives the answer for you. Fine. So you integrate x power 2, that's x power 2. You're integrating x square. Okay, let me crack this code. Integrating x square, so that will give you x cubed divided by 3. Integrating x power 2, that may give you x cube divided by 3. After that, you are substituting limits. Say 1 comma 0, 1 first will be substituted, so it will become 1 by 3 minus 0 by 3. Fine. So that will be 1 by 3 is the answer. So that's how we can solve this. Fine. So I think it's equal to, fine, not equal to, here is integrate. Fine, that's how it works. Fine. So you can actually pass the limits like this. You can pass pi also, that is also possible. So that's how you can integrate and differentiate using this Sympy module. This is something very cool in Python. Okay, maybe if you know this already, it's okay, and I'm sorry for sorry for telling you again. And if you don't know this already, and I'm very happy to teach you new thing to you, right? So that's how it works. Thank you so much for coming walking with me through the course. Thank you so much, and I'll upload all the books in this experts, and you can watch out for me to for a lot of courses that is available there. I'll have courses on JavaScript, fundamentals of JavaScript, and fundamentals of JavaScript 2, Java. Then moving on, we have courses on Python, also object-oriented programming in Python, and GUI programming in Python. Like we have courses you can actually enroll. All these are free to learn. Java is actually premium because that's a 9 hours course. Okay, so that's premium course. That's complete. That will include everything in Java, like come from basics to advanced. So you can actually enroll in that if you want, and you can learn a programming language completely. This is something extra stuffs in Python, but you can learn Java completely. You can actually enroll in that if you want. And yeah, thank you so much for that's it. Mm. Moving on, let me finish it off with only one expression. Okay, so that is not all related to SymPy. Okay, that's not related to SymPy. That's called as evaluate. Okay, so that's simple. I'll say eval function. That's a function available in Python. You've been knowing it, so it's a function available in Python. That's also a mathematical function. So that's why I'm telling it here. I'll say 5 minus 2 divided by. Quickly tell it again. Okay, no problem. Okay, let me have an expression like this. So to calculate this expression, I have to use something called as BODMAS rule, right? So BODMAS rule, you may be knowing this already. BODMAS rule. So you have to simply put eval, and eval stands for evaluate, and put the expression, and it will do it for you in terms of BODMAS rule. It's called answer is 10.8. It shows something like that, and the answer is correct. Actually, this is BODMAS rule. That's how you can create you can evaluate an expression in Python script. Okay, shell, it is very easy, just give the expression, it will do it for you. But script, if you want some expression to be calculated, you can use eval function. That is not at all related to SymPy. That's actually the eval function available in Python by default. Fine, Python 3. Fine, that's how it works. Thank you so much. Is thank you are very small words, but I want myself to thank you. So after that, please do leave a rating for me. That will highly motivate me to do a lot of courses in Udemy. Please do leave a rating and review. Thank you.